Hello, and welcome to a practice edition of our unit on regular polygons. Today, we're going to be working with our regular polygons, and we have to remember, well, if you have all this in your notes already, that's great. We're going to have to remember the area of a regular polygon is equal to 1/2 times the apothem times the perimeter. If you don't remember, the apothem goes from the center of a polygon down to the that is it's a perpendicular bisector to one of these sides. So AP is the apothem here, and the radius would be either AR or AS. It goes from the center to one of the endpoints on the polygon. So area is equal to 1/2 times the area, times the apothem times the perimeter. Now, if you also remember, a regular polygon is when all the sides and angles in a polygon are congruent. So we also have to remember the sum of interior angles is n minus 2, the number of sides minus 2 times 180 degrees. And if we wanted one interior angle, it'd be n minus 2 times 180, all divided by the number of sides or the number of angles. If you want to use exterior angles, then all exterior angles is always equal to 360. That's a personal choice. So looking at this first one, we have a triangle. Technically, we have two different choices that we could use, according to what we've studied so far, to solve for this. First one is area is equal to 1/2 base times height. The other is what we just learned today. Area is equal to 1/2 times the apothem times the perimeter. Either one will work. I'm going to demonstrate both of them, starting with the apothem part. So if you notice, we have here the base, or we have one of the sides, so that means that we have, since we have the apothem here, we could say that this is 7 and splits it into 7 and 7 because it is a perpendicular bisector. We should also recognize that since this is a regular polygon, this is a regular triangle, it is equal angular. So that means all angles are 60 degrees. This one in the bottom left corner will be divided or bisected to 30 and 30. The moment we do that, we have a 30, 60, 90 triangle. And if you notice, we have the b root 3 side of a 30, 60, 90. So b root 3 is then equal to 7. If we wanted b by itself, we would divide both sides by root 3. We get b is equal to 7 over root 3, which we cannot have, so we multiply the numerator and the denominator by that root 3. b would then be equal to 7 root 3 all over 3. So we have our b value, which is our apothem, which is what we kind of desired. Now we also need the perimeter to solve this. So this is this equation. Apothem would be 7 root 3 over 3. The perimeter would be equal to 14 plus 14 plus 14 because all sides are congruent, or 14 times 3, which is 42. So now we have all the information we need to solve for the area using the regular polygons equation. 7 root 3 over 3 multiplied with 42. So I personally would do 1/2. Ooh, that's way too large. Let's fix that. I would do that's way too small now. I would do 1/2 multiplied with 42 first, just to make it easier because 42 is even. We end up with 21 multiplied with 7 root 3 over 3. We also notice that 3 goes perfectly into 21, which is great because now we have 7 times 7. Denominators will just kind of vanish. Area would then be equal to 49 root 3. This is measured in meters. Okay. Now, if you notice, we also have this 1/2 base times height equation. So I'm going to redo this problem with that information instead. We know that the base of this is 14, which would be, if we drew an altitude on here, or a height, we could say that it is 7 and 7 still, which is great. Except this time around, we're using the 60 degrees here. This would be our 30, and notice our b side is equal to 7, which is even better because that makes our height 7 root 3. As we know, area is equal to 1/2 base, 14, times the height, 7 root 3. And we could do 14 times 1/2, which is 7. 7 times 7 root 3, which is now equal to, you guessed it, 49 root 3. So either way works. Personally, I would use the area is equal to 1/2 base times height, the one that we already used, the one we already know. Ooh, this is supposed to be squared. Can't believe I missed that. So it should be equal. This one is the one I personally prefer just because, one, we already have the base. It's already given. And then two, it's much easier to work with. In this particular problem, the 30, 60, 90 is easier to work with because the B side is a whole number. So this is more so personal preference. You kind of look at what you have. Sometimes if you are given, for instance, the apothem to start with, it might be easier to use 1/2 times apothem times the perimeter, but it's case by case. I personally would work with this as often as I could, the 1/2 base times height. Now this one is slightly different, and I'm going to pull up my calculator for this because we are going to need it. Make sure you are in the right mode, because if you're in the wrong mode, you will need to fix that. Make sure you're in degrees. If you notice, this one is a pentagon. A pentagon has 540 degrees. If you don't remember that, this is 5 minus 2 times 180 degrees, which means 3 times 180, which is equal to 540. 540 divided by the number of sides, or the number of angles, will give us 108 degrees, which means every interior angle is 108 degrees, which also means that this radius that is bisecting the 108 degrees makes it 54 degrees on each part of this, each part of the bisected angle. So we have 54 degrees here. We know that the 10 is the side, which means it gets split to 5 and 5, and we can start solving for the apothem. The apothem would be the opposite side, or x here. If you want to put a, that's a little confusing because we don't want to confuse it with adjacent. But we definitely need the opposite side and the adjacent side of this 54. So that means we need to use the tangent function. Tangent of 54 is equal to x over 5. Okay, so multiplying both sides by 5, we end up getting x is equal to 5 times the tangent of 54. Now, normally we would just multiply this out and we would get x as some value. For this sake, I'm going to do two different versions of this. X is approximately, and I'm going to do this here, 5 times the tangent of 54. 6.88 rounds to 6.9. And our answer changes depending on how we use this. I'm going to leave it like this for now, and then I'm going to do a second version with this 6.9. Okay. Perimeter, we should know, is 10 times 5 because of the 5 sides, so this is 50. And we can now use our equation 1/2 times the apothem times the perimeter. The apothem, though, can be used as this x value, 5 times the tangent of 54. Now, why would I use this instead of the 6.9? Well, because this is the most accurate version of what the apothem is. If you don't believe me, you'll see in 1 second. Perimeter is 50, so we could do this, multiply these two, or we could just put this all into our calculator right away. We could say 0.5 times 5 times the tangent of 54. Make sure you close that parentheses before you multiply that 50. You get 172.04. So the area is approximately 172.0. If I use this as our apothem, our answer is slightly different. So I'm going to do this in a different color. Area would then be equal to 1/2 times the apothem of 6.9, the approximation of it, and 50. If we do this in our calculator, we get 0.5 times 6.9 times 50, and we get 172.5. Now, I know it seems like a small difference between these two answers, but the bigger these numbers get, the further away these answers will be, especially if you round to a different decimal. Where you round is going to be very, very important in these problems. So I personally, if I were you, I'd get used to kind of doing something like this, the 5 times tangent 54. But I understand that it can be very, very annoying. So what I would do, if you don't like to use the 5 tangent 54, but you want to use a decimal, I would round the 6.8819 as many decimals as you can. For instance, I would probably use at least 3 or 4 decimals. 6.88, and then round maybe to the what was it, tens, hundreds, thousands, maybe even the 10,000s place. The tens, hundreds, the thousands place would also be very, very good, because if you do this problem again, 6.882.5 times 6.882 times 50, our answer gets a lot closer to what we had over here. But just note, you want to be as accurate as possible, especially when you end up rounding in the beginning part of your problem. All right, so 3 and 4. 3 hopefully is a piece of cake. Hopefully you recognize that this is a square, and a square can be solved using base times height. Personally, I would use area is equal to 1/2, or not 1/2, just base times height, and we should get 15 times 15, which is 225. If you thought about this, awesome. If you didn't and you wanted to use the apothem is equal 1/2 the apothem times perimeter, you absolutely could do that too. We would still get the same answer. If you don't believe me, try it out. This one, however, is a hexagon. There is no other way to do this other than finding the apothem, which is a given, and the perimeter, which we don't have yet. So this is a hexagon. We have 6 sides, so we take 6 minus 2 times the 180, which gives us 720 degrees. We divide that by the number of sides, 6, which gives us 120 degrees, and we split that up when it comes to the radius, 60 degrees and 60 degrees, which is beautiful because now we have a triangle here that's 30, 60, 90. Even better, well, this always happens with the hexagon, which is very, very nice. Hexagons are beautiful because we end up with 30, 60, 90 every single time. Working with, regular hexagons anyway. Notice that the apothem is the b root 3 side, so we could say this is equal to b root 3, which means if we divide both sides by root 3 to get this by itself, the root 3's cancel out, and b is equal to 5, which is great because then we have a side of 5, which means the full length is equal to 10. Since it's regular, all sides are congruent, so that means the perimeter is equal to 60 centimeters. Apothem is still 5 root 3, and now we could work with this. So now we have area is equal to 1/2 times 1, that's a 2, 1/2 times 5 root 3 times 60. Once again, I'm going to multiply the even number with the 1/2 to make it easier. 30 times 5 root 3, which is then equal to 150 root 3. This was centimeters, so this is centimeters squared. All right. So we have another triangle here. Obviously, you could use base times height, or 1/2 base times height, or the 1/2 apothem times the perimeter. So give that one a shot. This one's also a square, so this one hopefully you could realize, oh, I could use base times height here. And then we have another hexagon. So try these 3 out on your own. And I'll see if you do have any questions, please ask. And hopefully this is enough basis for you to get through it. There is a homework assignment. Make sure you complete that before the end of the day. And I'll see you in the next one. Bye.